Hi everybody, welcome to another session. Today we will see the rules of definite integrals. In the previous video we saw what is the difference between definite and indefinite integral, and we talked about definite integral or regular integral, which they have some limits from the beginning and at the end. So now let's see some basic rules for this type of integrals. So the first rule is when you are integrating a constant c, it's just the constant c that times b minus d. Okay, so let's see one example. The example we will see is the integral of 5 dx from 1 to 4. So this is, we say that it's 5x, x is from 1 to 4, and it is 5 times 4 minus 1, which is 5 times 3, which is 15. So as you can see here, we said before that the integral of any constant is the unknown, which is dx, which is dx times that constant plus a c. This is for indefinite integral. For the definite integral, we just apply that for the border of the integral, which is f of b minus f of a. And that's exactly what we did here, times the constant. The constant, we can take it out. Okay, the second rule is the power rule. So if you have a power, you remember in the indefinite integral we said if you have a power of any kind, it's the unknown to the power of n plus 1 divided by n plus 1 plus c. But for the definite integral, we just take that, remove our c, and we use the border that we have here. So let's see this example that we have here. So the integral of x to the power of 3 from 0 to 2 is equal to the unknown, which is x to the power of 3 plus 1 divided by 3 plus 1, okay, between the border 0 and 2, which is equal to x to the power 4 over 4 from 0 to 2, which is equal to 2 to the 4 divided by 2 to the 4 divided by 4 minus 0 to the 4 over 4, which is 2 to the 4, which is 16 over 4, minus 0 to the 4 is 0, so it is 0 is equal to 4. Okay, for the next one is the constant multiple rule. The constant multiple rule, we have a constant times a function, we take the constant outside, exactly same as the previous one we did in the indefinite integrals. So what we have here is our c times the integral from a to the b of f of x. For as example, the integral of 2x from 1 to 3 is equal to the 2 times the integral from 1 to 3 x dx, and we said before that the integral of x is x squared divided by 2, but we should respect the interval, which is 1 to 3, is 2 times 3 to the power of 2 over 2 minus 1 to the power of 2 over 2, which is 2 times 9 over 2 minus 1 over 2, which is 2 times 8 over 2, which is 2 times 4, which is 8. Okay, for the sum rules, same thing. You just take the integral of each one apart. Like this will be the integral from a to up to b of fx dx plus the integral from a to b of gx dx. As example for that, integral from 0 to 1 x squared plus x, and here we can see that we have two different functions, so we can separate them and we can write this is equal to 0, the integral from 0 to 1 x squared dx plus the integral from 0 to 1 x dx, which is equal to, the first one is x to the power of 3 divided by 3 from 0 to 1 plus the x squared divided by 2 from 0 to 1, which is equal to 1 to the power of 3 over 3 minus 0 to the power of 3 over 3, and you just continue the calculation, which is easy. The fifth rule is the difference rule. Same thing as the addition rule. You have two different functions, one minus another one. You just split them, each function by itself. As example for this, we have the integral of x squared minus x3. You have this is function, this is another function. I will split them apart. So I will have the integral from 1 to 2 x squared dx minus integral from 1 to 2 of 3x dx. You can see even here the minus, I took it outside. I can write plus and have the minus here, and after that take the minus 3 out, but you can see it is same thing. Okay, so we can do like this is equal to the integral from 1 to 2 x squared dx minus 3 the integral from 1 to 2 x dx, which is equal to x cubed divided by 3 divided by 3 1 to 2 minus 3 times x squared over 2 from 1 to 2, and you can just keep doing the calculation. I can go more if you want. So this will give us x to the power 2 to the power of 3 over 3 minus 1 over 3, okay, to the power of 3 minus 3 times 2 to the power of 2 divided by 2 minus 1 over 2 to the power of 2. Okay, the only thing you are doing here is just a simple calculation, simple math calculation. The exponential rule, this is the most interesting one, because actually there is nothing to change. It's look scary, but it is not. The integral of exponential x dx is just the exponential of x dx plus c. There is nothing to do there. So because the derivative of exponential x is exponential of x, and same thing, the integral of exponential of x is x. So we have the integral from 0 to the 1. I can just say this is the exponential of x from 0 to 1, okay, which is exponential of 1 minus exponential of 0, which is e minus 1. Okay, very, very easy. It's look difficult, but it's not. For the natural logs, same thing, very easy. The only thing you should remember, the integral of 1 over x is completely the log of the absolute value of x. That's the only thing you need, plus a constant c. That's the only thing you need to remember. So as for our example, integral of 1 over x over interval a to b, which will be the log of the absolute value of x inside that interval, which will be absolute value of b, log of absolute value of b minus the log of absolute value of a. So as example for this is one, I have 1 over x, which will be, I can go directly, if you remember you can directly go here, but if you don't remember you go step by step. So which is the log of the absolute value of x from 1 to 4, which is the log of the absolute value of 4 minus the log of absolute value of 1, which is log of 4 minus 0, which is log of 4, because you know that the log of 1 is always 0. Now we can see some basic trigonometry function. Here I will talk about just the sine and the cos, but for more deeper understanding there is also the tangent and the cotangent and cosine and the sec. So for the integral of sine x dx from in interval a to b is minus cos x. You just remember also for indefinite integral, the integral of sine x is minus cos x plus c. Same thing. Here we have minus cos x inside the interval. Easy example. The integral of sine x in this interval 0 to pi is equal to, I will directly apply that, minus cos x from 0 to pi, which is minus cos pi plus cos 0, okay, which equal to minus, what you know what cos pi is, which is minus 1, and you know cos 0 is 1, plus 1 is equal to 2. Okay, so why we wrote here plus, we did not write minus, because it's minus minus cos 0, which give us a plus cos directly. We don't need to go that. You are in advanced classes of mathematics, so usually you don't need to go over small steps that you can see. So the integral of cos x is sine x. There is nothing to worry about it. There is no sine. You just flip this from sine to cos. So our example here is the integral of cos x. I will just apply it directly, sine x, which is from 0 to pi over 2, okay, which is equal to sine pi over 2 minus sine of 0, which is 1 minus 0, which is 1. If you don't understand or you don't remember how you can find the sine of 0 or sine of pi over 2, you can go to the unit circle in the video of trig function where we saw how to find the sine and cos directly from unit circle, and you will see that cos 0 is 1, sine 0 is 0.